Okay. Welcome to my YouTube channel, I guess. So to do a vessel offset measurement or to do vessel offset measurement rather, what you need basically is just you can use AutoCAD as allowed. So you just create a new this thing. Um, so the ritual for setting up AutoCAD UN, although for the scope of this work, the changes really doesn't really matter, or the settings doesn't really matter, but let's just get over it. Okay, right. So next step would be to, well, obviously the expectation is that you already have your image, right? Let me open this, right? So this is my sheet or the one for of interest for me, right? So if you check the project requirements, which are pasted, it says plan, elevation, and vessel photograph. So from this particular image, this is the plan, then this is the what's the other one? An elevation. This is the elevation view. This to our elevation view, right? This is our elevation view. So yeah, this is the work. So all you have to do is just okay, for your AutoCAD is set up, you can just drag the and drop the image in AutoCAD, right? Insertion points, scale factor, can just leave that as one. Then rotation 0 is done. Then Z enter. Alright. So you can see the image is in AutoCAD now. Right? Yeah. So you will see that this is not like a okay, how do I start explain? So you see that the sensors are not particularly there yet. So you have to figure out your position for the sensors. But one of the things that you find this is for this is that as I'm taking this on this, it's not so easy to see my cursor. So you can right click, maybe you can select the image, then you can just increase the fading, I just fade it out a little. So that when my cursor is on it, I can see it clear and I can still see this, right? So with that done, escape. All you have to do next is just scale this, right? So for you to scale it, you need to draw a line across this PL, polyline, right? So you want to do something like this. So I already know that from the website I got this vessel, I already know that the length of this vessel is 16 meter total. So can just leave that there. Let me change the color to red. Can just press PR, right? So if you bring something like this, change the color to red just for visualization. Then now you want to draw PL again, can just draw it somewhere around there. Then press 16 because I know my length is 16. But before I press that 16, you should have your auto on. Okay. So now I can press 16. Yeah. So it's done. Can see how wide the 16 is. So now press align this one. Right. So it says select object. So the object in question is all of this, the image and the line together. So when you're done, you press enter or space, then you do something like this. So you have your whole snap on, then you do this, right? I've joined that point to that point. Then this other point, I want to join it to the end of the 16th line. Then you press enter because you are done. Scale objects based on alignment points. Yes. Yeah, lovely. So you see that the red line and the white line are now the same. So you can just delete the white line now. And so now when you do GIST to check the length of the boats, you see it should be 60 meters or not. So 60 meters you can see. So now this is my plan view, this is my elevation view. So the first thing you want to do is find your or determine where your center point is, your CRP is, continuous reference point, right? So I can put my CRP almost anywhere actually. So I'll put mine here, let me put it here. Yes. Draw it down, draw it up. Alright. So now I'm going to maintain that straight line for both of them. Now all I have to do now is draw CRP for this plan view to PL. Okay, let me just I think I would like to maintain this. Okay. So can maintain whites or for better visualization again. Red up to me actually. So look for a way to identify this your CRP. So it can be like X polyline again. Can just draw an X around there. Yeah, sorry. What's not still on? You enter. So this is not necessary actually. It's not compulsory rather. So I want to put a text here. CRP. Consider. Oh, sorry, sorry. M M text. Abi. Yeah, M text. So left click, right click, Abi left click. Then just type what you want. CRP. Can change the fonts. Time Roman. CI. Okay. Oh, sorry. Time Roman. Right. So CRP. Right. So I can just this. No. Enter. So I'm not going to the basic control of AutoCAD because I assume or believe that I should have idea, I should be able to figure this one out. So enter. So I want to move or I want to copy the CO, right? So I'm copying it based on that point. So that's my CRP, right? For elevation, that's my CRP. For plan view, this is my elevation, right? So you don't need this joining. You can just break it. Okay, right? Mhm. So let's say I think I will do two, right? So let's say my echo sounder is there. I'll be my multi-beam echo sounder transducer. The transducer for multi-beam echo sounder is there, right? So I can just draw something. Let's say is there a rectangle stuff? Yeah, rectangle. So rectangle here, right? So something that might be helpful is that you need to link the top with the down, right? So let's see this PL. Can you see the center is identified? So you just trace that center down, right? So the multi-beam echo standard, the transducer will go down, like inside the water. If this is the water level, this is water level here. Let's draw another one. PL. So I think this is better blue. Okay. So let's say the echo sounder is on this side or maybe on this side. Let's put it on this side instead. So what I have to do now is just CO this name, this CRP, put it here. Um, so one of the most useful this thing is this auto, but at times it can be stressful. So you can just name this MBES trans. Okay. Alright, multi-beam code standard transition. Then you do this. Then you cannot copy this. Right. Using that center point. This is very important. So let's put it on this side. Right. Yeah. So that's my multi-beam echo sounder. So let me do something else. Should I? Yeah. Let me do one more. So let's say my DGPS receiver, PL, no, not PL. I can't go again. Let's assume that this is my GNSS receiver, right? So I have to trace it down again. So PL, the center, see it's glowing, select it. So your own might not glow. You might want to come and play around with this. This is what is causing it to glow, geometric center. You see that now that my okay, now that my snap, my auto is not is going around, but which I don't want to just do this. Trace it down again, right? So then, okay, if this is where it is on the height, on the plan view, where is that same thing? Let's name it before we start moving. CO, copy, CO for copy, right? So you want to edit this to be maybe GNSS, right? CO, no, you want to copy it with the square. To make this one slightly different, I can draw maybe um here. Let's cook something. Oh, this is not necessary, but it gets. So CO again. Uh, so let's say it's exactly at the middle on the plan view, right? Yeah, this will work. So what you want to do next is that you now maybe in your Word document have a table, insert table 3, 4, 5, 6, 7. Yeah, serial number if you find necessary, or just sensor X, Y, Z. So want to be microsounder trans trans User, you can obviously you can figure the rest out. Then Genesis. So next is right to start doing the offset stuff. So you do dist, right? I've measured from this continuous reference point to this. So you can check this information here. You see it's saying distance, then it's saying delta x and delta y. So this delta x is telling you, oh, this point is 0.711 meters to the x-axis of the continuous reference point, which is what you need. So you can just copy it. And y is 0 because it's on the line on the y. Is that right? Yeah, there's no movement, there's no shift on the y-axis, which is this way. Is on 0 at the y-axis. So that's why. So yes, you come to this place. Was that the most immunogenesis? Control V, then y is 0. Alright, so Z, let's go and get our Z. So our Z is as simple as coming here. So this place is just height. So PL, sorry, GIST again. So from this one, continuous reference point, to, please be careful of snapping. So the one of interest now is Y. This Y is your new Z for this particular view. So let's copy that. So you have this. I've copied unnecessary stuff, but Control V. Yeah, so that's it. Then what else? So for the multi-beam transducer, the same thing. DIST to the center again, right? So you see, you have your X and Y. Control C. So the same way this transducer is like, it could have been on this side, so it's absolutely up to you. Okay, Control V. Obviously, that would affect the sign too. Control X, Control V. And this was minus, sorry, minus. Okay. So now to go and get our Z for that one, GIST again, right? So you have this is your Z now. Very simple something, I guess. So yeah, so how you now make this semantics, like how you make it fine? Maybe you are drawing this thing, maybe you are drawing cardinal point, proper cardinal point stuff, and you are doing all these things. That's absolutely up to you. Styling, how you are presenting the results, etc. is absolutely up to you. But you also need to include the vessel photograph. I have my own vessel photograph, so you get that and present appropriately for the coursework. On that note, bye bye from my YouTube channel, I guess. Like and subscribe. Adios. Adios.